Good afternoon, folks, and thank you for taking time to join us today on our webinar, where we will be highlighting 10 great features in ANSYS R16, specifically for CFD. My name is Joel Thacker, and I'm a Senior Applications Engineer at Wild Analysis in the UK. The webinar, I estimate, is going to run for anywhere between 25 to 30 minutes, at the end of which we will have a Q&A session. I just want to make you aware that all our attendees are currently on mute. So if you do have any questions on the content that you see today or any comments, feel free to post them directly onto the questions dialog box during the course of the webinar, and I'll aim to address them at the end. Okay. For those of you who are new to Wild Analysis, who haven't spoken to us before, I just want to mention that we are ANSYS channel partners based in the UK. Our service includes software sales, benchmarking, demos, training, after-sales support, and also consultancy for their ANSYS user base. We also have a portfolio of other software products catered to specific industries or physics groups. I would encourage you to visit our website and get in touch with us if you're interested in ANSYS or any of the other software suites that we offer. Okay, so let's talk a little bit about ANSYS Release 16, which is the focus of our discussion today. As with other ANSYS releases, ANSYS Release 16 is packed with new upgrades, new features, new models. We've revisited some of our workflows and we've made it better. The presentation today is going to highlight just a few of these features and these models. And our engineers here at Wild Analysis have handpicked these features based on what we think our client base use the most, what we usually see at our ANSYS help desk, so queries that are raised by the current ANSYS user base, and also, with our discussions with the clients, what do the clients want to see in future releases of ANSYS? ANSYS have taken this on board and worked with us and clients to make new models happen and to make existing workflows better. Obviously, this is just a small list of an entire document of upgrades and new features. So if you're interested in that, give us a buzz, and we can make that document available on request. Okay, so starting at the very top, let's talk about the GUI and ease of access. This is in Fluent. Those of you who are used to Fluent, or those of you who have seen Fluent in the past, will note that the Fluent GUI has changed. It's gone to a tree structure. And that falls in line with all the other ANSYS products, whether it's in FEA or whether it's CFD, like in CFX. Moreover, you don't have to drill down through, 2 or 3 dialog boxes to get to, let's say, a UDF checkbox or a boundary condition. It's all based on right mouse button click now. So if you're on the turbulence button, you can right mouse a button click and go straight to the turbulence model that you require. You can also save contour and definition and vector definitions. So this was a feature that was long-standing in CFX, but you couldn't do this really in Fluent. What that means is that if you had, let's say, an analysis that you set up, and oriented your geometry or your contour or your vector plot in a certain way, and also to certain scales of pressure, velocity, whatever. When you closed Fluent back in R15 and previous releases, you lost all that information automatically. But now in R16, you can save that. You can save those definitions of contour and vector plots, such that when you run, iteration 2 or iteration 15 of your analysis, you don't have to go back and set that up again. So, again, streamlining the workflow and just making things a little quicker for our user base. You can also create a custom user interface in version 16, and that's, again, a request from the clients who tell us there's probably 1 or 2 CFD gurus within the department, and the rest of them don't want to have to drill through, dialog boxes or the Fluent GUI. What they want to be able to do is just go to specific buttons that's, catered to their application, and kick off the software that way. So now what you can do is, for your specific application, you can set up your own custom GUI, and that, it includes full checkboxes, radio buttons, for boundary conditions, for meshing even if you want, because Fluent has its own meshing capabilities and T-Grid. So again, just making life easier for those who need quick access to Fluent. There is new documentation with examples on how to set your custom GUI up. If you're interested in this, feel free to contact us and we'll send you the documentation, or we can train you on how to do this. Post-processing in CFX and data handling also, I must say. In the past, in R16 and prior releases, transient runs always had large amounts of data. They would eat up hard disk space quite rapidly. And in R15 and previous releases, you could say, I'm not interested in the whole list of variables or the whole list of field inbuilt functions that CFX comes with. I'm only interested in, let's say, pressure, velocity, and some other custom variable. And you could save that at every time step or every other time step. The problem with that is that you would still be solving for those variables of interest across the entire domain. You probably don't care for the entire domain. So in this example over here, we've got an airfoil, and we're looking at Mach number. So that's a custom. That could be a custom variable, but we're looking at that across a transient run only on certain planes across the airfoil. So only data on those planes will get saved. Again, this is going to speed up the analysis because you have less time going in and out of the solver and writing to disk. And also, you're saving disk space because, well, haven't got, the entire list of variables across the entire domain. Mesh-related issues. In Fluent, your mesh had to be pretty good back in the day. In order to get a converged solution, it would take, sometimes it would take quite long for convergence to occur, but Fluent have got around this by making the meshing, making the mesher more robust that comes in from ANSYS or from T-Grid. And also they've got some other features within Fluent that can help you do that. For example, we've got the mapped mesh interface for fluid solid or fluid fluid domains. So back in the day, if you had dirty CAD or someone gave you a mesh geometry where two domains weren't aligned perfectly, such that, in the case over here, zone 2 is penetrating into zone 1 or overlapping into zone 1, and between the two domains there is a gap, the solver would crash, or you would have a very hard time getting it to converge. Well, instead of using interface now, what we're using, what we can also use rather, is a mapped mesh. And what that does is basically take nodes from zone 1 and map it onto zone 2, or vice versa, depending which way you're going. And that completely, removes any issues of overlap or any gap between the two zones. Again, this is a new feature in Fluent. There are some limitations to this, so again, the full documentation can, tell you exactly when and where it can be used. But mainly, what you need to bear in mind is that if you're going to use a mapped mesh interface, you need to have a fluid domain talking to either another fluid domain or another solid domain. There has to be at least one fluid domain. Within Fluent meshing, you now have the ability to preview your cell size before you hit the mesh button. Again, that's pretty good because you want to be able to see, if you're capturing geometric features based on your grid size. So in the first plot that you see over here, you can see the grid size before we hit the mesh button. And you can see, okay, you can make an engineering judgment. Is that big or is that small? Am I going to capture, the holes over here? Am I going to capture the radius of the bend? you can make that call basically. But let's say you've already done the mesh and you've already got results. Again, you can look at your mesh element size on a contour plot and see, okay, my graph or my contour plot looks a bit patchy, but I think I've got a decent enough mesh over there. Or my mesh elements are too big in this region, which is why I'm getting either some sort of discontinuity or my contour plot looks very patchy and I need to, make my mesh more refined. Sometimes, actually very often, we tend to use the polyhedra function within Fluent. For those of you who haven't used this function before, if you have a tetrahedral mesh that's brought into Fluent, you can convert this to polyhedra. And again, that came out a few versions ago, and it was there to basically assist with convergence, because sometimes with tetrahedral mesh you get very skewed elements, or your aspect ratio becomes very large. Polyhedra is a workaround this basically. So in release 15 for a 7 to 8 million element multi-phase analysis, it would take hours, more than 5 hours sometimes, to polyhedralize the entire domain. But on version 16, it's dropped down to 1.7 or 2 hours, which is a massive, is a massive improvement on something like a 50 to 60 million element domain analysis. Okay, in terms of getting things done faster, the quote that I've got there on the screen, it comes directly from ANSYS, and ANSYS are confident that R16 scales better than any other commercial code. So if you look at Fluent, really, on the right-hand side over here, you can see that because what we've got is the blue line, which is theoretical line that says, how as you increase the number of cores, how your productivity or how your analysis should speed up, and it's a linear trend. And you can see Fluent pretty much hugs that line, unless you go to very high number of cores, which is about 36,000, and then you start getting some deviations. For most of our client base, we're sitting in the 0 to hundreds, if not a few thousand cores. So in that region over there, the trend is extremely linear, so which is a good thing, obviously. Same thing in CFX, which is the graph on the left. You can see the difference between R15 and R16. R16 is, is sped up by a factor of at least 2 across a multi-phase transient analysis. It's a turbine analysis that we're looking at over here with 64 million elements. Again, once you have about 64 or 2,000 cores, the analysis has sped up quite rapidly. From time to time, we get requests for diffusion-driven flows. These are flows where diffusion is the main transporting mechanism for fluid from one point to another point. And in R15, if you look at the graph on the left over here, even after 1,000 iterations in CFX, we would not get convergence. Whereas in version 16 now, after 200 iterations itself, our variable of interest has basically stabilized. So again, you're saving massive amounts of time between 200 and 1,000, over 800 iterations. That is a massive improvement. Talking a little bit about solver capabilities and numerics over here. Capturing shocks for compressible flow is obviously an important feature for our clients, and capturing not just the shocks but also the high resolution of the shocks across an expansion fan or reflected shocks is quite important. And ANSYS Fluent has got the row flux method. It's a new method that's added for the pressure-based solver, and it's much, much better than the existing reach out method. And you can see that across supersonic airfall right now. You can see the resolution across a shock wave or a shock front. Okay, in terms of turbulence, within Fluent, we've got two new models, a baseline Omega model and an SBES. A little bit about the baseline model first. It's basically Omega-based model, and it's Fluent's new strategy, and it's going to be used to slowly phase out the realizable K-epsilon model. The SBES method is a combination of RANS and LES. So Fluent has had this for a while, but the difference is the user can choose what RANS model they want to use, and then have a blending factor to move into the LES zone. So that's the key. You're not limited to what Fluent says should be used on on a RANS/LES model. You can choose what RANS model you want to use. In CFX, there have been some improvements to the SST model. So what I've got over here is standard step over here, and the red arrow indicates where reattachment occurs in simulation, and the blue arrow over here indicates experiment. And as you can see, if you check the reattachment box in CFX, the numerics are much better, such that CFD and experiment tie up better together. Obviously, in version 15, you could have got CFD to match up with experiment if you had a very fine resolution mesh over here, but then again, that's going to take longer to solve. If you use the checkbox method and a decent mesh, you're going to get much closer for a lot less hassle. In terms of integration to the other ANSYS products, we have one-way coupling to harmonic and response analysis in ANSYS Mechanical. So if you've run a transient analysis in Fluent and you've decomposed your pressure field, your transient pressure field, and obtained a spectra for that pressure field on the vibrating glass, on the wall structure basically, you can import that pressure spectra into ANSYS Mechanical as a CGNS file, and then look at the response at those frequencies, across that spectra in ANSYS Mechanical. So again, that's one-way coupling to ANSYS Mechanical for acoustics. We obviously have two-way FSI, full-blown two-way FSI, but this is mainly just for acoustics that I'm talking about. Another issue, another request that came out from clients over the years has been the ability to do one-way and two-way FSI on porous domains. Well, in version 16, that can be done now. So if you've got a porous jump, typically these are used to model grills or sheets of, perforated vents, for example. If you've got that, you can do a full two-way FSI on a porous jump or a thin porous domain, basically. And that's what this is showing over here. So, you've got your total deformations and you've got your fluid fields, which are driving the deformation. Okay, for thermal radiation in Fluent, the surface-to-surface radiation model is much quicker. In R15 and previous releases, when you set up surface-to-surface radiation, the view factor calculation, especially if you had a lot of surfaces, if you're looking at an internal electronics box, for example, a lot of things are shielded from others. One surface could be shielded from another surface, and there are a lot of surfaces that need to talk to each other. So that would take a long time to solve, just the view factor calculation. But again, in R16, we've dropped this down by a factor of roughly 4. So again, that's making life easier and faster for the client base. So just to close up over here, ANSYS CFD R16, it's in they made it easier to use. You've got a tree structure in Fluent. You can build your own custom GUI. It's quicker because we've got HPC that scales better than any other commercial code. We've got the ability to handle data better. So you're not, your solver is not spending time reading and writing in and out of disk, basically. It's actually going ahead and doing the computation. Improved solvers for turbulence, for shock capture. Also, it's integrated. Acoustics talks to mechanical. We've got two-way FSI that works with porous domains. Obviously, what I've shown again over here is just 10 features that we think are the most useful for our client base. If you're interested in the full host of updates and revisions, get in touch with us, and there's a full release document that we can give you. Okay. Before I take up any questions, I just want to mention that we have a similar webinar for the FEA side of ANSYS Release 16 on Friday the 20th of March at 11 a.m. All times are GMT. We've also got a GTAM webinar on optimization and how it works with ANSYS Mechanical on the 1st of April at 2 p.m. And then, of course, we've got one for thermal and structural response of electronic components across the entire software, ANSYS software suite. Okay, at this point, I will take any questions that you've got. So feel free to post any questions into the questions dialog box. Okay, I've got a question here regarding meshing in parallel. And the question really is, can meshing be done in parallel in Workbench? Yes, it definitely can be done in parallel in Workbench. That's something that came out not in version 16, but that came out in version 16 itself. So yeah, the short answer to that is yes. Okay. If there are no more questions, we will end the webinar now. Okay, I've got another one. Is it possible to use porous baffles in CFX as opposed to having... Yes, absolutely. And we can talk about that offline if you want. Yes, yes, absolutely. I mean, we use baffles, porous baffles all the time to model grills and other types of equipment. So it doesn't have to be a subdomain. It could be even a porous sheet if you wanted, based on specified area fraction. Okay, I've got another one for pipe-soil interaction for offshore engineering. I'm going to have to ask you to expand on that question, if that's all right, because, well, we've got specialist software for pipe-soil interaction. So what exactly are you looking for on the pipe-soil interaction? Okay. Okay, there's another question. While we're waiting for that, there's another question that's come in to turbo machinery. Turbo machinery, there's been a lot of work that's been done on turbo machinery, specifically in CFX. There's about 10 slides worth of that itself. So we're happy to speak to you offline, and we can send you documentation on that. Okay, going back to the pipe soil interaction, effect of debris flow on pipe soil interaction. Well, I think this is what you're asking, but if you're trying to model erosion or sedimentation, again, that can be done within ANSYS CFX and an ANSYS FLUENT. I've recently seen a methodology, I think it was an ANSYS FLUENT in R16, of course, where as soil, or let's say as particles are going past a pipe, for example, it won't just give you the erosion rate, grams per year, for example, of wall, but it'll also change the geometry for you. Yeah. So as the erosion rate is calculated, it will actually change the geometry for you on the fly. I believe that's an ANSYS FLUENT. Again, we can talk about that offline. I've got another question for having introduced adjoint feature in CFX. The answer to that is no. Adjoint, as of right now, is only within FLUENT. There has been some work done on adjoint solver and how you specify, what can move and what can be optimized, but nothing in CFX right now. Again, another question on GPUs. Vast topic. A lot of work done on this. We'll take it up offline if that's all right. Okay. It looks okay. Is the CFX measure updated as part of the release? Okay, correct me if I'm wrong over here, but when you say CFX measure, I'm guessing you mean the ANSYS measure, because CFX mesh was, well, we've stopped supporting that. It's no longer being developed, a few releases back. But yes, okay, fine. ANSYS mesh as a whole has been updated. We've brought in things from ISIM into ANSYS mesh. We've brought in some features from Gambit into ANSYS mesh, to appease the old Fluent users also. So we have better shrink wrapping methodologies within the ANSYS mesh also. Okay, there's a long question over here, so I'm just gonna. Sorry, before I move on to the next question, just gonna finish up with the last question. Is it possible to refine the mesh with a shape other than a sphere? Absolutely. Again, we can talk about this offline. I mean, you can refine the mesh using points, dummy bodies of any shape, a line. So if you imagine a wing and you have the drag, the vortex in the downstream region, the mesh in that region can be discretized using a dummy object, a sphere, a point, a line, anything really. So we can, we can talk about that, and we can send you tutorials on how to do that if you're interested. Convergence issues in Fluent. Combining dynamic mesh, unsteady compressible Rance turbulence. Convergence simply in parallel, but in version 14 or 15. Question is, overall convergence of 16 improved using, yes. So the question was, for a dynamic mesh that is unsteady and using incompressible Rance turbulence, basically there was issues in getting any kind of convergence and, getting the solver to go to completion in 15 and 14. Is it better in version 16? Yes, and I'm actually using dynamic mesh quite often nowadays for in-cylinder type applications and for FSI, for two-way FSI. So yes, because the solver itself is more forgiving of a mesh, of the mesh that comes in, you will have better luck with version 16. Back in the day, something that possibly didn't work in version, in a version of Fluent could work in CFX, but now they're pretty much the same because Fluent is more forgiving of your mesh. Okay. Don't see any other questions coming in. As always, you're probably going to have questions the minute this webinar ends. So feel free to send us an email. You've got our details on the screen over there. Talk to us via social media. Follow us on YouTube. All right. Thanks for your time. Take care. Bye-bye.